All right, this is our last lesson video for chapter 15, and this starts off with a discussion of a titration problem between a weak acid and a strong base, but I'm going to go through all the different steps for this in the next video in Canvas, and so you can just watch that to see how to go through all this, and it kind of walks you through that. All right, so let's skip down to the indicators. So again, an indicator is something that changes color based on pH, and we use these to determine where the equivalence point is in the titration. So it tells us when to stop doing the titration, and there are various indicators that you can use. So there's a couple of different ways you can do it too. So you don't have to use an indicator, you can use a pH meter, which is something that you can put into the solution, and it reads the pH for you at every point in the titration. So the way that indicators work is, and you'll need to know the specifics for these, is not just that they turn color, but actually how they work. So most of them are weak acids. So we put the H in front of the IN just to show that it's an acid that's an indicator. And when it splits apart, you get H plus and then that negative ion from the indicator. So if you do the Ka equation for this, products over reactants, you can see the equation that it would have for this. And you're going to have to use this sometimes when they give you concentrations of things and ask you about the pH or the Ka, various things they could ask you with this equation. Color change occurs as the proton is lost or gained. And this part right here is especially important. So for most indicators, about 1/10 of the initial form must be converted into the new form. So what this means is basically that this has one color and this has a different color. So as it switches to the new ion, it's going to change colors. So about 1/10 of the initial form must be converted into the new form before a new color is apparent. So sometimes they won't give you numbers. They expect that you understand this relationship, that when it's about 1/10, that's when the color change is going to happen. And there's an example on page 743 that shows you how to do this. So if you want to see an example for that, you can take a look at that. The indicator color changes are sharp, occurring with just a little bit of titrant, just like when we do the titration. And it's important that you choose an indicator that matches the equivalence point of your titration. So you want the color change of the indicator to happen when the equivalence point is also happening. You want them to match up. And not all indicators turn color at the same pH. So you can even see there's a page in your textbook that has all the indicators, and it shows all the colors they change and what pHs, and you'll see it's like a rainbow, and there's all different pHs of all of the different indicators of when they turn color. Strong acid, strong base titrations may use indicators with endpoints as far apart as 5 and 9, so they don't always turn color right at 1 pH. There's kind of a range. And so you want to make sure you choose an indicator that matches what you're trying to do. So sometimes on the AP exam, they'll talk about a titration, and then they'll give you several choices for indicators, and they'll explain when the indicator turns color. You just want to make sure that the indicator turns color at the same pH as the equivalence point. And you might have to calculate that pH, but then you can match that up. And I'm going to go through an example of some of these problems in the next video.